Okay, can you hear me well?
Yes, very well.
Okay, good. So today we are going to focus on the expression node. It's not about the expression in general. I know you can use expression on every node, but basically we're going to focus on just on this topic in particular. As starting point, I would suggest to use to see this guide here in Nukepedia. It's really very good because it's starting from the first steps and then it goes a little bit crazier at the end, but it's really, really nice. So what I've done is a collection that you can find here on the Tony collecting toolkit. It's a collection just for using the expression nodes. It's divided by categories here. And it's just because, I mean, you can just learn something new. You can just learn how to do stuff in a different ways. And of course, why it's good to use the expression node, because you will save time, and at the same time you will work smarter and faster. So this is the main reason, because instead of using, I don't know, 10 different nodes, you will do everything inside only one node. So there are different types of expression nodes. The first one is the main one, is this one. We're gonna start from scratch. So sorry in advance if for someone it's gonna be a little bit boring, but it's good that people that from other department or even compositor that don't use this node is good to start with. So this is the let's say main node. Then we have the merge expression node. Is basically, you see the interface is the same of the previous one. The only difference is that it's taking two inputs and the color is blue. That's why it's blue. It's because with that one, we can just merge exactly as the classic merge node of Nuke. So what can we do with that one? We can do fancy stuff. For example, we can replicate the merge from Photoshop, for example, and we can create a different new types of merging two inputs. So for example, we have all these long string that, I mean, here is basically impossible to read, but the good part is that when you see the capital letter A or B, it's because it's taking inputs from the input A or B. So that's the only difference, I mean, compared to the previous node. Then we have the deep expression. So it's working with the deep. At the end of this workshop, you're going to see basically how it works. And then we have the particle expression. I've done also another collection with the particles. So here you can find a little bit of the particle expressions examples, but I don't want to touch it today. So the expression node here is by default, it has the RGBA channels. So for example, this is the for the red channel, and here is taking the input for the red channel. This is for the green, blue, and then for the alpha. So this is the text field where we can do input and just typing stuff for relative to the blue, green, and red, and of course alpha channel. How it works? The expression nodes works for every single pixel. Imagine that, okay, I'm typing stuff. So this stuff is going to run for this pixel, this one, and so on till the end of the image. So that's why it's so important to get this one, because we will see it soon. We have some default variables that are already in Nuke by default, and we can use them as starting point. So let's see here. We're going to take this input, it's the classic color bar. And here, let's start from scratch. So I'm going to type a new expression. And here I'm going to put R, G, B, A. So our output is the same of the input, but let's try to, for example, switch the R channel with the green one. So for example, here I'm gonna just delete it, or I'm gonna type 0. So now my red channel is 0. So if you see here, there's no red channel anymore. But if I'm gonna try to put here G and here red, see the result different. Okay, so basically what I'm gonna say now every pixel with the red channel, it becomes the green one, and the opposite way. Here another example. Let me just delete this one. So what I'm saying here I'm saying the red channel becomes the green one. The green becomes the red, and even the blue is the red one. So the result of my image is going to be this one. My alpha channel now is white, is black. But let me just introduce this new variable that you see here. It's the x and y. This is giving me the position of my single pixel. If you remember, I said that this node is running for every single pixel. So if I check here, the first pixel on top left is 0. So that's why my alpha channel is 0. If I go here to the next one, it's 1, 2, 3, and so on, till the end of my image. The resolution of my image is 2048, and the last pixel is 2047 because it's starting from 0. That's why. So I can just do this plus 1, and I will get the exact resolution from 1 to the resolution. So what is happening? What is happening here? If I put, for example, I create a new expression. If I type here in the red channel the x, and in the green one the y, I will get the, okay, here, yes, sorry, without any input, I will get everything yellow. Okay, so let me just delete this one. Now it's red because it's giving me the coordinates in the horizontal way of my image. And if I add y, the green channel, I will get also the coordinates of this pixel, this one, and so on. Okay. So let's add another variable, is the width and height. This gives me, for example, width. Let's delete this one. This is giving me the width, so the resolution of my image, and is by default is this one. So the default of Nuke. And now I don't see anything. Okay, here you see now this is giving me just the final resolution of my image on the red channel. Let's make it more interesting. I can also let's say combine what we learned before with the RGBA with the coordinates. So for example, what I can do, I can just, for example, translate horizontally my red channel. So for example, let's delete this one. Okay. Okay. Let me delete this. No. So this is the original image. I can just translate the red channel horizontally by, I don't know, 100 pixels. So every single pixel on the red channel is going to be translated by 10 pixels, or translated in the other way by negative, with a negative value, with in this way. I have just to put inside the branches the x and y. Okay. Now, yes, sorry, I just forgot. The bad part of the expression node is that it's using a rigid syntax, so like in every other scripting language or something like that. But the bad part is not giving me error message. So for example, if I create usually, you know, the copy node without any alpha input, it's giving me error node. in this case, the expression node, if I do something wrong, so for example, here I type something stupid, just basically it has no output. I mean, the output doesn't change. So that's the only, let's say, error message that I have. By the way, yeah, I will finish then with these default variables. So for example, I can introduce also cx and cy. So, sorry, without any input. So this is giving me the center of the image. The center of my image is 0, and it's going to be normalized between -1 and +1. This is good, for example, if we want to use it as a vector or something like that. And last one is frame. Now, every pixel will get the, we'll get, let's see, just the red channel. We get the exactly number of my current frame. So now I'm frame 3. You see here in the red one, frame 3. Frame 90 is value, the value is 90. Let's see after that, how can we use that? Now, so we said that we have by default these variables, but we can also create new variables that we can use already inside the node or in other nodes. So we can use the upper part of our expression node to create 4 different variables, but we can add even more. So for example, I can declare a new variable called just var is equal to this one here. So y divided height. This is giving me just a normalization with the height of my image. So if I will put this one, for example, with a r, and here, instead of green, I'm going to put var. You see here, it will change the green channel with this new variable here. But the same, if I disconnect this one, no, won't work. Okay, so this is giving me the variable that I declare here. Then, like in every other node, I can also create a new variable here, adding new knob. For example, I can just add a new slider called var6 between 0 and 10. And it will appear here in the user tab. So what I have here, I have 4 different variables that I declared in this new node. var1 is this value, var2, 3, and 4. It's just a test. I don't know what will happen. And then variable number 5, I connect it to this slider. And I can use directly the variable 5 in this value, and it will change the green, it will affect the green channel. Okay, so let's see just the green channel, how it will change. You see here, it's going to change just with the slider. I can also add the new variable that I created. It's called var6. So I can, I don't know, multiply var6. Now it's 0. So I can just add something new. So I can just create a lot of different things without putting everything here. So for example, what I can do is avoiding the new variables. I can just put everything here. So for example, I can put this one, multiply the green channel, multiplied, I don't know, this one here. I mean, the result doesn't change if I put stuff here or there. It's just because here is more elegant and readable, I would say. Then I can also use variables from one expression node to another one. You see here, they are connected with the green line. So I declared in this case is the same node as the previous one, but the good part is in this expression, I can use a variable 5 that I declared in this previous node here. So what I've done, I have variable is equal to expression 12, so this node here, dot variable, so the name of the variable. And in my, where is it? Yeah, the red channel, if I move the slider, it will affect my variable in this other node. So this is really good because we can, of course, if, let's say, if we have all the 4 variables already declared, we can do it in a new node, something like that. Then let's see, for example, just with a small summary, how we can create an UV map. Usually in every company, we have this node, this fancy and everything. So I'm using this node too. But if we go inside the node, what we can find is just basically this expression node. So what it does, basically, we can create a new expression node. And in the red channel, we can just type x divided with. I'm gonna just put here double branch plus 0.5 to avoid the division, the 0 division. So you see here it's just a gradient between 0 and 1. The same, I'm gonna do it with the vertical, in the vertical way. So I'm gonna put y plus 0.5, right? I close the branches, divided I. So we have here a perfect UV map that I've done only in 2 seconds. For example, if you are in a company that you don't have this, you can, I know, create it with a ramp, but it's really annoying. So you see here, it's just with basically one small code and 2 variables that we can do it. Then let's see what else we can do here. We can do also operations. So we saw already the classic for operation, plus, minus, divided, and multiply. But we have also different types. So for example, we have the clamp. It's basically doing the exact what the clamp node does. Minimum and maximum. So let's see, let's take this image here. We can, for example, just plus RGB. So I can create a new node, so I can just replicate it. I can just do operation instead of in different text. I can do everything in only one. So here I just check the checkbox, and I'm gonna put R plus G plus B. And you see the result. Every RGB now is taking this value here. I can do, for sure, I can do the same here. For example, I can just plus it. So just select R plus B plus G. But of course, I will use 2 nodes at least, and it's going to be more complicated and more complex. So I can do the same here. Also, my alpha now is black. Let's say, okay, I want to put the alpha like the sum. I can, for sure, just put a shuffle node and just saying, okay, now my alpha, every channel, even my alpha is going to be this. But why should I waste a new node? I can just copy and paste it here. So now my alpha has the same value as the RGB, as the sum. Or I don't know, I want to take the alpha, like the maximum value between the 3 of them. So I can just say max in the branches R, comma, G, comma, B. So if I remember, before I said the expression node will run for every single pixel. So it will check, okay, this pixel here, originally it has the value 0.42 for the red one, the green one, and the blue one. So it will take, of course, the maximum value of this pixel between the RGB. This pixel here, and alpha is going to be that value there. So we see here the operation. I did it before, so I'm taking the maximum value. And it's going to be the same, for example, if I remove the saturation and I put the maximum value, it's exactly the same, but I did it just in a different way with the expression. So let's make it a little bit complex with this operation. I can create a really, in a fast way, a color difference key. So what it does basically different operations between the channels. So here, for example, I use this node. I did this node, but the tutorial is from Steve. I don't remember the name, but yeah. So if I go inside here, I have just a different expression node that does a different operation between just a simple operation between the channels. But it's really good when I have to key something, for example, really hard to key. So sometimes I don't see, I don't know, for example, I need to key the, the lips, for example. So what I do usually here, I go here and I start scrolling down the various results. Of course, since they are operation between the channels, I can get also negative values. So that's why it's not clumped, the black and the white. So just be careful with that. So for example, let's see here, yeah, maybe red minus green and minus blue. It's giving me this one. So I go up a little bit with the exposure. It doesn't work. Maybe the first one is not so bad. So here, I say here, so I start to clump. And of course, the image is really noisy and with low resolution, but you get, for example, the result, more or less. And this is really good, for example, when you want to key something. And usually it's hard with the Luma key. It's not hard, it's just different. So just with simple operation between the red, green, and blue, I can get this fancy result. Now, usually in comp, what we have the maps of our characters, stuff, props, and everything. So usually what we get is just without the alpha. So we have the let's say red for one object, green for another one, and so on. So usually what we do, we can just shuffle stuff and then plus it, just doing max, whatever. So I don't want to go into this topic. So you can do stuff. You see here how many nodes I'm using. I'm using a lot of nodes. So just to create my final alpha. I can do exactly the same just with one node. So for example, here I'm using the plus. So what I can do without the clump, let's say, I can just plus it how we did before. And of course, in the overlay, yeah, here, I will get a value more than 1. So I can, that's why I was clumping that. Or if you like, for example, the max, I can just do the same here with the max operation. So it's the same exactly as this one, okay? Nothing will change, but you will save time and of course memory, so you will work faster. Now, the condition, the classic condition, so of course, if you know already something about the coding scripting, this is the classic one. So how it works, so basically we are starting, so we have an expression, a classic condition. So if the condition is true, does something here. If it's false, so just follow this new branch. And then we have the result. So we can have two different results, one result. So if condition 1, then just do the operation or value 1, just return something. Else, just return something different, just do a different operation. How can we translate, so this one here that usually in Python, Java, whatever, I mean, we can do it in this way. We can translate it basically with the question mark and the 2 points. So we put at the start the condition, then the question mark is going to be our then. So if condition, at the beginning there's no if, but imagine here there is a if condition, blah, 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 then just do the operation one, else do the second one. So let's see here some, an example. We take always this image. So let's check the alpha, okay? Our alpha is 0 in this case. I can check the alpha. So if alpha is more than 0, then do something. So let's see here. I can just put a grade node just on the alpha, and I can tweak the offset. Or I can just put the auto alpha. Okay. So I don't know. I can just say, no. Okay. Yeah. This was another. Yeah. Only if. So here we don't have the then condition. So it's just the if. So if alpha more than 0, just do nothing. So basically, we can just interpolate this stuff with the if then as condition. So I can create the alpha channel. Here I have my roto of the girl. Beautiful. And what can I say? I just declared a new variable called number and is1. So what it does is saying if alpha is equal is this number here, so is 1, then the red one, the red pixel is red. Otherwise, else is 0. So basically what it does, here we have our alpha with, of course, this solved here. So our number is not 1. Here in the core math is 1, but here not. So I'm expecting that the result is just taking the core math of the girl, okay? So that why did I put two, I mean here equal? Because if I want to use it, I have to use the double one. I cannot use just just only one. So this is for equal. This is the OR operation. This is different, so it's just the opposite of the other one. And this is AND. So let's see now these two. So here, if I'm gonna check my result, it's giving me the RGB value only where my alpha is 1. So only in the core math, basically. When my alpha I see here, starts to be different, I mean, the different has a different number from 1, so it will be 0. You see here. Now I can also compare the alpha. So if alpha is minor of that number, so it's less than 1, do this operation. So it's just basically doing the opposite. How can I do if I want to take only, because here you see the image only where alpha is 0. So I want to say, okay, I like where alpha is less than 0, but I would less than 1, sorry. But I would like to take it only where alpha is more than 0, so only where the alpha exists. So I can just concatenate it. For example, I can say this one, less than 0. I'm going to put the double branches. And alpha is more than 0. And I'm going to close it. OK, now I can just paste it everywhere. And if I did it correct, yeah, you see, I took, I mean, the RGB values only where alpha is less than 1 and more than 0. So in between here, only in that region here. let's say, in our edge. Then another good stuff is I have here always my math, so RGB, and I have if then color. So I want to have a full alpha, so equal to 1, where my R, if this pixel basically can be RGB, but more than 0. Okay, it doesn't matter which one is more than 0. It will put alpha equal to 1 only if one of them is more than 0. So basically only where the math exists. So this is my result, basically. I have only alpha 1 and 0, where if I go up with the exposure, you see here only blue is more than 0, but it doesn't matter. I mean, he will put the alpha 1. So it's the same, I don't know if I have it here from Tony, the alpha binary. I know, yeah. It's the same of alpha binary from Tony. Something else that can be good in our comp. So for example, when we do tech check, we have also to check if we have negative pixel, non-pixel, infinite, and blah, blah. So we can here basically just created some negative values in a random way. So you see here the red is negative. So here with this expression, I'm going to say just basically if red is less than 0, just put it equal to 1000, otherwise 0. So why 1000? Because it will be really, really bright. And if I put here just a blur node, I see immediately the result. So here in my image, I have all these pixels, all these negative values, pixel values. That's why, I mean, it's good to fix them. What can we do with just this example here, just with basic operations, math operation? We can also do the dispel. Of course, everyone does dispel with API dispel or whatever dispel we use. But we can also create something different with the expression node. So here I basically just declare a new variable. So if I put this simple expression here, so the maximum between 0 and green channel less the sum between is just the average of the red and the blue channel, I will get the classic dispel one with the average mode. So between, sorry, I go down. So you see here, this is the classic green dispel, and this is the blue dispel here. And of course, I can create all the different, let's say, kind of dispel. So with red limits, here you can study by your own how it works. So for example, here there is this new variable, limit percentage. I can just tweak the limit. I don't want to go deeper with this one, but you can check by your own. Then, what else can we do with the math operation? I can create just a IO graph, and this is really nice because it's like the classic color lookup. It's good to understand how, for example, the grade node works, how every single knob is working, what basically they do in our image. So here we have just a gradient that we did with the ramp. And with the expression, we translate all the operation, let's say, in just this line. So if I'm going to tweak the gain, you see how my line is changing. So it's the same of what I do here in the color lookup. So I'm going to just tweak this one. Or for example, when I tweak the black point, what it does on our image. Or for example, always no one knows what the toe does. So for example, if I put here my toe, you see here, this is my result, or compare, I don't know, to the difference between this one and the lift, for example. So it will just help me to get better what one knob does. I took here also from this node from Nukepedia. So I can just create a new hue ID. Basically here I have my ID object. You see I have purple IDs, so something really crazy. It's not just RGB. And I can just see here the expression. Okay, so here it's really hard to understand what it does, so I can just put it here in a new sticky note, and I can read it better. So it's really hard to get what everything here, what is happening here, but it's good to divide this one in different branches. So I can just study this one. So okay, this is the if operation. This is the then condition. So I can just divide it go step by step and see here how it works. So this is the power, so the exponential by 2, and so on. So I can study just step by step my expression. So even if it's in just one line, and basically with this node, I can, for example, you do a new ID, just tweaking this one and expand it, or and so on. The Cryptomat also works with expression. And then, yeah, we see here the negative values, how we can also check, but also kill the negative values. For example, here I'm just adding and creating new values here. Usually they are on blacks. So I'm going to check here my negative values with the same expression as before. You see here I have some of them. And with the blur, I can just, they are popping up a little bit. So I can also kill the values, just offsetting by left and right my values that I have here. So if I put x plus x offset or y plus y offset, I can just, let's see where they are. So yeah, this one here. I can just, for example, use this pixel and move it there. And I don't see, I mean, if they are more or less the same value, I won't see any difference between them. Or otherwise, if they are really, really blacks and not crazy values, I can also use the absolute value. The absolute value, I can use it with this expression, so ABS. What it does, so basically it transforms the negative in the positive number. So for example, if it's -1, it will give you +1. If this value is, for example, minus 0.002, it will give me just the positive 1. And basically, it will be more or less the same value if it's really close to 0. Then here, yeah, I have all the other functions. If you want to check, there is the link. I will try to go a little bit faster to see something a little bit fancy. Everything that you see here, I mean, the script is quite huge, but I don't want to basically start to talk about every single thing, but you can find it here. So they are in creations. For example, you have all this kind of stuff here. So you can see how to create, for example, the noise, or basically lines. It's really good because you can create animated lines in just a really easy way, just using the scene and cause basically expression, math, or whatever. You can create the circles, radials. I mean, you can create a lot of stuff. And let's see just basically how can we use this stuff. I can here, for example, create an image. I don't know if you can see it. It's an image with just points. So I'm trying to create points between, I don't know, maybe 100, every 100 pixel. I can just set it, okay, every 200 pixel. Now it's 100. I can just delete them. Okay, a little bit. Now you see the pixel. And for example, with the convolve, I can just create, this is the filter of my convolve. I can create, for example, a wall. just a little bit because it's quite slow.
4K, good.
Yeah, it's also 4K. Okay, maybe died.
Uh-oh.
Okay, sorry. I have another one here, so I can open it faster. Okay. I can just reduce it. Let's see. Let's put this one. Yeah, the convolution is a little bit slow. Oh yeah, maybe let's see here. It's working faster. Maybe this one is faster. So basically what it does is it can create a kind of wall, I don't know, with hexagon. Usually we see this kind of wall in, you know, the futuristic hologram, something like that. So it's really nice because we can just here create an hexagon and just put in these points and we can, okay, we can say the distance and stuff like that. And at the same time, we can just catch the space between one hexagon and the other one. So I remember maybe this one, Helge used it for the first Captain Marvel to create a divisor of Captain Marvel. Also, what else can we use? We can create some kind of bricks just using the UV map and the ST map. So we can create this one, or this is a little bit more complex. We can create a kind of bricks with the UV map. And if I'm gonna put this one, you see the result. And this is just a test, of course. If I put all together this knowledge, okay, here just basically in this node, I just created this node really quickly. We can do a kind of texture pattern that we like. So every single node here does something. You see this one here, this one there, and so on. And if I put together all this stuff here, I can get something more complex, more nice, and blah, blah. We have some kind of problem with the edges and aliasing, but yeah. A little bit here, we have operation on the alpha channel and at the same time on pixels. So this is really good, for example, to check the infinity pixel, the non-pixel. And it's the same as the how we check the negative values. Blah, blah, blah. Yeah, I'm skipping a lot of stuff. I want to just show you this one. It's a new section that I would like to implement. So here we said we can create the UV map really easily with the expression, and at the same time we can also transform with just an expression going from vectors to UV or the other way around. So from UV to vectors. How can we use this one? So for example, here I have just a rotopaint. Okay, here. This is just one rotopaint. I did connect this rotopaint to in this way. So we have a UV. I'm just using the smear node here to manipulate, to create. It's just like the liquify on Nukepedia. But if I use the smear node, I can create something really cool. So I can just move stuff and blah, blah on my image. So I can just going out with the ST map. And if I do here, I can create this image here, or at the same time, I can also invert the ST map with this expression here. You see, it's something really simple. We are just putting stuff together that we learned before. So I can just invert my STMap and more or less, okay, without any, I can get more or less the same image as before with some difference. We can also convert using this node here with vectors. And so we can use it driving just an ID distort or something like that. And we see here that using STMap or using vectors is giving me exactly the same value. So we talk about vectors. Imagine to have, okay, we have blood here. Okay, we have this kind of blood. It's moving. It's moving. Yeah, should move. I don't know why. Okay, yeah, should move. Yeah, you see here it's moving. Of course, this blood is a 2D element. It has no motion blur, something like that. We know that every single particle has the proper motion blur. So, for example, one point is going up, another one is a little bit heavier, so should go down, something like that. So it's not good if I'm going to apply something like that, the motion blur. So motion blur should be, I can just attach it to a transform that I tracked before. So this is not giving me the right motion blur. At the same time, what else I can do? I can just use the classic one here, but this is really heavy. And at the same time, if I have something just moving faster, or in this case with a lot of points, it will get a good result. So what's one solution? I can just paint it particle by particle, let's say. I can just paint my motion blur. Inside this node is using the same basic of the rotopaint transform we used before. But here, if I go inside, I have just a rotopaint that I convert this rotopaint into vectors. I'm just going to put the vectors in my main stream, and it will drive the vector blur, classic. So here you see the result. I don't like, for example, I don't know, the motion blur of this particle. So I can just take my smear node and just move it there a little bit. It's a little bit heavy, also this one, because it will convert my paint into vectors and so on. And then I can just tweak here my vector, my the multiply, my offset, or something like that. So I can basically have in my end the motion blur of every single particle, of every single point of my image. And this is basically using the expression to convert my paint, let's say, into vectors. Or I can paint directly the vectors on my image. Last one, another conversion. So, for example, I can go from UV into normal channel. So here, for example, I have my UVs of my helicopter. I can just convert it before into radiant and radiant to normal. And then, of course, I can use this normal to relight my helicopter. So it's a little bit, I have just a different approach. For example, with normal, I can just create an easier mask as I want, or I can do the other way around. So UV to normal and then normal to UV with just this expression. Then I can also extrapolate a kind of fake normal from my luma of my picture. You see here, basically using the matrix. I can just create this kind of normalized, and then using the same relight, I can, for example, tweak the direction of the light and use this one as a mask of, I don't know, my grade, something like that. Transform. And I don't want to open a new topic, but here we have some operation that we can do with 3D. For example, yeah, the normal pass-through light. A good thing is this one, the deep thickness, that, for example, I can, if I remove here, oh, sorry, you see the edge improving. So this is really good, especially when you work with smokes. So with transparent object, you will get a really kind of fake, soften, hold out, or merge with the deep. And basically, this is really simple. So it's just using this expression, and I'm adding and removing from the deep front and deep back. So yeah, maybe we are done. So I don't want to let you learn, of course, I don't know all this stuff, I mean, always, but what is good is that you know at least the basics. So for example, if you don't remember the exact syntax of stuff, you can always use Google Forum, something like that, but you know already what to look for. So that's why it's good to use, at least to learn this kind of stuff. And it's not so complex. So it's just basic math and basic scripting and coding knowledge. That's it.
Thanks, Andrea. We still have 5 minutes, and I think many of you have some questions. So I think that's great time if you or everybody understood everything, which is also amazing. From my experience, I from time to time I'm going to this area all the time. Let's put it like that. But if you first time looking on something like that and you're intimidated, I think you should be. Yes, there is like, it's very fast starting to be convoluted. It's one line expression starting to be crazy, but I would highly recommend to dig into at least beginning, because it's super helpful when you want, for example, just to have maximum for two things, maximum for RGB, for example, just the maximum value of that, or average of them. Or like, you know, there's so many little things that in your comp, from the moment you're trying these ones, for example, deep front, deep back, how to soften your deep when you're connecting it. It's such an easy and basic thing to do that each one of us can do it after like 1 minute of reading. So there are many things that very smart people using to make stuff complicated or to make life better, but it's very complicated to understand. But if you familiar with very basics, you kind of you will make your life easier in easy way. So without going crazy, like if statement is, I mean, if you will have a look, like in almost every comp, you will find that somebody is using something like that, in so many ways, like in merges, in the mix. If this, do that. If there is alpha, turn this on. If there is no alpha in input, turn this off. It's such a useful thing that I would highly recommend. Maybe not go to this crazy long kind of like lines, but there's many things that you can just okay, learned, next one. And that's already very important, just not to be scared of this kind of like of this area of compositing.
Did you guys record the session perhaps?
I tried, and I became way better in recording lately, so it looks like I'm
good
recording.
So it means we can watch it anytime we want, right?
Yeah, it's on the server.
And here we share, of course, the script and everything. So here at the bottom you have all the useful links that you will find, some guides, tutorials, something like that. For expression in particular, I would recommend the website of this guy. It's really useful for expression and TCL. So it will start like me from scratch, so with basic stuff, just transform, something like that. And he will go a little bit crazier at the end. But yeah, as we said, start simple, and that's it.
Right. Then, Andrea, thank you very much. It was very interesting. It's super nice. And everybody who are in Trickster, I think we have access to, not I think, we have access to all the scripts, whoever is outside.
I mean, I can share it for everyone because it's not using everything. With NDA stuff.
So. Yeah, you can put it in the link and WhatsApp group. Okay, thanks. Let's start our day.
Thank you, Andrea. Thank you.
Thank you.
Thank
Yeah,
you.
thank you very
Bye
much.
bye.
Thank you.
Thanks. Bye.
Thank you.
Ding, 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 ding.